All right, so in 13.7, we are entering the unit circle here. So the unit circle is part of trigonometry where we use 30, 60, 90 and our 45, 45, 90 special right triangles mostly to find different sine, cosine, and tangent values, all right? It eventually expands further into that, but for right now we're gonna start with these two special right triangles. In a 30, 60, 90 special right triangle, we know that the hypotenuse is twice as long as the shortest side, and the medium side is equal to the short side times the square root of 3. In my 45, 45, 90 triangle, we know that both of the short sides, we can use x for those, and the longest side is equal to the short side times the square root of 2. So in the unit circle, we want the radius to equal 1. Okay, this is important because when we rewrite these special right triangles, we're going to reorient these so where the hypotenuse is equal to 1. So in my 30, 60, 90, we want the hypotenuse, which we know is 2x, we want the hypotenuse to equal 1. Well, if the hypotenuse is equal to 1, and I solve this for x, we divide 2 on both sides, that means that x is equal to 1/2, okay? Remember, x represents the shortest side, as we can see right here. So if I rewrite the sides here, we said we want the hypotenuse to be 1. We just said that we found the shortest side to equal 1/2. And we know that the medium side is the short side times the square root of 3. All right, so 1/2 square root 3. And we usually like to write this as square root 3 over 2. All right, because 1/2 times something is the same as that thing divided by 2. So this is what we're going to use in our unit circle. All right, the hypotenuse is equal to 1, the shortest side is equal to 1/2, and the medium side is square root 3 over 2. In my 45, 45, 90, we know, again, we want that the hypotenuse to equal 1. So in my 45, 45, 90, we want the hypotenuse, which is x square root 2, we want this to equal 1. So if this is the case, I'm going to divide both sides by the square root of 2. Now we don't want to have a radical in the denominator, so I'm going to rationalize that. I'm going to multiply by square root 2 over square root 2. And so we get x equals square root 2 over 2. All right, so again, x represents the short side. So in my 45, 45, 90 triangle, the short side is square root 2 over 2. And the hypotenuse, again, is going to equal 1. So we're going to use this information to complete all parts of my unit circle, all right? So we're going to be given basically different angle measures or whether they're in radians or degrees, and we're going to try to find the values of the sine, cosine, and tangent, okay? But again, this is the key information that you need to have, that you need to know, all right? So let's start off with the basics. Let's say, for example, I have my unit circle. Again, the distance from the center to any point on the circle, no matter which way I go, is always equal to 1. All right, the radius is always going to be 1 no matter which way I go. That's the whole idea behind the unit circle. So let's say I just go right, up, left, and down, all right, 90-degree increments. So you can see here in the orange, I have that measurement listed in radians. And then you can see in blue, I have that same measurement listed in degrees. Okay, we just talked about how to convert from radians to degrees and vice versa. And so I have those angle measures listed there. Now you can see in the black, I have the ordered pairs, right? These ordered pairs tell me the x value and the y value. And you can see for this first point here, I am going 1 unit to the right and 0 up or down. So basically what this means is that we don't really have to use our unit circles in this, or sorry, our special right triangles in this one because we don't have any triangles that we're forming. But these are values for sine and cosine. We'll talk about that in a minute, what that means. But these are kind of your basic ones that we kind of already talked about in the 13.6 section. But this is just kind of a reminder for us before we get into the special right triangles. If we move along the unit circle, and let's say we make a 45-degree rotation. Okay, so I'm moving 45 degrees, and we know that 45 degrees is the same as pi over 4. So again, I've written down all the degree measures and their corresponding radian measures in case you forgot, all right? But again, if you forgot how to go back and forth between those, just watch the last section of the notes, and that will tell you how to convert back and forth. Basically, what's happening here is no matter whether I have my right triangle drawn in the first quadrant, in the second quadrant, third quadrant, or fourth quadrant, I have these 45, 45, 90 special right triangles. And so what we know is that in a 45, 45, 90 special right triangle, the hypotenuse is 1, and both the sides are square root 2 over 2. So if I were to write the coordinates, well, how much do I move in the x direction? I move square root 2 over 2. And how much do I move in the y direction? I also go up square root 2 over 2. And if I were to do the same thing over here in the second quadrant, it'd be the exact same scenario, except in this case I'm going left, so I'm going left negative square root 2 over 2, and I'm still going up, so that would be a positive value, right? You can imagine if I drew this right triangle here, I'm going left, so this is a negative square root 2 over 2, and then I'm going up, which is why we have a positive square root 2 over 2, okay? But we're still using that 45, 45, 90 special right triangle, all right? We can continue this same idea in the third quadrant, except this time I'm going left and I'm going down. So I know that both my x and y values will be negative. So negative square root 2 over 2 and another negative square root 2 over 2. And then in quadrant 4, I'm going right and down. So because I'm going to the right, my x value will be positive, and because I'm going down, my y value will be negative. Okay, so we get these 4 coordinates based on 45-degree increments, right? I travel 45 degrees, we get to a right angle, travel 45 degrees, we get to 180, travel 45 degrees. And so we can kind of move around in these 45-degree increments to find these different ordered pairs, okay? And again, these ordered pairs are all based off my 45, 45, 90 special right triangle, okay? So you're always going to see the square root 2 over 2 when you've got your 45, 45, 90-degree increments. Now let's go to when I do 30-degree increments, all right? When I move 30 degrees, again, we know that in this special right triangle, we're going to say that the hypotenuse is equal to 1, the shortest side is 1/2, and the medium side is square root 3 over 2, right? We said that this is the truth from what we've got right here, right? When we change it to a radius of 1, we know this is what's going to be happening in my 30, 60, 90 special right triangle. So at this point right here, again, I'm looking for the x value and the y value. Well, the x value, I go square root 3 over 2 to the right, and then I go up 1/2. So that would be the ordered pair. That would be the location of this point right here. And then if I go, you can see we've got 30 degrees from the 180, which would put me here. And so if I have another 30, 60, 90 triangle right here, we've got our 30 degrees, 60 degrees. Well, in this case, I'm moving left square root 3 over 2, which would be a negative square root 3 over 2. And then I'm going up 1/2, which would be a positive 1/2. So at this point right here, it's going to be very similar, but this time we just said that we have a negative square root 3 over 2 and a positive 1/2, right? I go left square root 3 over 2, and I go up 1/2, and that would get me to this point. Over here, we've got negative square root 3 over 2 because I'm going left, and I'm also going down, so that means I'm going to have a negative 1/2 as well. And then over here in quadrant 4, I'm going to the right, and then I'm going down. So because I'm going right, it's a positive square root 3 over 2, and because I'm going down, it's a negative 1/2, right? So again, these are your ordered pairs whenever you have these 30-degree increments, okay? You have a 30, 60, 90 special right triangle, and so these are going to be your ordered pairs as you progress around using those 30, 60, 90 right triangles. All right, and the last possible scenario over here is we still have a 30, 60, 90 special right triangle, but now notice we've rotated 60 degrees up instead of just 30 degrees. So in this case here, we know that my hypotenuse is 1, the shortest side is 1/2, and the medium side is square root 3 over 2. All right, so if I think about how much I go to the right, that's my x value, I go right 1/2, and then we go up square root 3 over 2, so that's my y value. And then I can keep rotating this 60 degrees around the circle. And if I do that, we kind of, again, have this same scenario right here where I've got 60, 30. This time I'm going left 1/2, but I'm still going up square root 3 over 2, okay? So we're going to kind of do the same pattern as we've been doing. And that means that this point is going to be negative 1/2 square root 3 over 2. If I were to think about quadrant 3 here, well, I'm going left 1/2 and down square root 3 over 2, so they're both going to be negative. This would be negative 1/2 negative square root 3 over 2. And then in quadrant 4, I go right 1/2 and down square root 3 over 2. So we go right 1/2 and down square root 3 over 2. All right, and so that would be, again, these are the coordinates of these key points that are formed from your special right triangle. Okay, so kind of putting it all together, you can see that we're going to have different x and y values depending on what kind of special right triangle we have that's formed in my unit circle here. All right, the key thing to remember, all right, is that when you have x comma y, your x value represents the cosine and your y value represents the sine. Okay, that's always going to be true. So if I look here, if I were to ask you, for example, the cosine of 60 degrees, the cosine is the x value, so the cosine of 60 would be 1/2. If I were to ask you for the sine of 30, well, the sine is the y value at 30 degrees, so the sine of 30 would also be 1/2. All right, so that's kind of how that is going to work with your x and y values. X is cosine and y is sine. So this is your y value. Cosine is your x value. And then the tangent is equal to y over x. All right, in other words, that's your sine over cosine. Okay, so two ways to think about that. You can think about your y value divided by your x value, or you can think of sine divided by cosine. So let's go ahead and we're going to evaluate the sine of 60. Now, we know that the sine of 60, if we go up to our graph here, I've got a 60-degree angle. We know the sine is the y value, so I know my sine is going to be square root 3 over 2 because my y value is square root 3 over 2, right? That's my up and down value. So what I'm going to make you do is I'm going to make you draw these special right triangles for each one, and we know that we want a 60-degree angle, right? There's 30. We know from my special right triangle that we've got 1. This is going to be 1/2. This is going to be square root 3 over 2. And so if I'm looking for the sine of 60, what this really means is what is the y value when the angle is 60 degrees, right? That's what this is really asking me. So when I have a 60-degree angle, that means that my y value is square root 3 over 2. So we know that the sine of 60 degrees is square root 3 over 2. All right? Next up, I want to know what is the cosine of 7 pi over 6. Well, 7 pi over 6 is going to be in my third quadrant right here. Okay, there we see my 7 pi over 6. And so we know that my triangle is going to have to look something like this. All right, so we're going to have the right angle. We've got a 30-degree angle, 60-degree angle. And so we know that in a 30, 60, 90, the longest side is 1, the shortest side is 1/2, and the medium side is square root 3 over 2. One thing we have to pay attention now is my directions, right? Because I'm moving left, I have to have a negative square root 3 over 2. And because I'm moving down, I have to have a negative 1/2, right? We moved to the left and we moved down. So those are both negative values. So what the cosine is asking me is, hey, what is the x value when the angle is 7 pi over 6, right? That's what this question is asking me. Now, if you're not sure where 7 pi over 6 is and you forgot and you want to change it 2 degrees, remember you can take 7 pi over 6 and you can multiply it by 180 over pi, okay? If you do this and you start reducing your pi's and you reduce your numbers, you're going to get 210 degrees. And you should realize that in your unit circle, 210 degrees is going to be right here just past the 180, okay? So we know this is the same as 210 degrees. But what it's asking is what is the x value when the angle is, again, 210, and the x value is, again, left and right. That's going to be negative square root 3 over 2. So the cosine of 7 pi over 6 is negative square root 3 over 2. All right, and that would be your answer. All right, the tangent of 315 degrees. Well, if I think about my unit circle, we know that 315, here's 90, here's 90, 180, 270. It's going to be right over here, right? If I take 270 plus 45 degrees, that's going to give me that 315 degrees, okay? So I want to be right here in that fourth quadrant. And if I'm in that fourth quadrant, that means that I'm going to have this 45, 45, 90 special right triangle, right? Because I know that it's this 270 plus 45. And in this special right triangle, we know that the hypotenuse is 1. Both of these sides are square root 2 over 2. And we know that because I'm going to the right, this square root 2 over 2 is positive. But because I'm going down, this square root 2 over 2 is negative, all right? So if I'm looking for the tangent, what this means is find y over x, right? That's like the sine over the cosine when the angle is 315 degrees, okay? So what that means is I'm going to take the y value. Now my y value is negative square root 2 over 2, and I'm going to divide that by the x value, which is positive square root 2 over 2. Well, I know that if I have the same thing on top and bottom, right, in the numerator and denominator, that is just equal to 1. And so because we have a negative up here, my answer will just be negative 1. So that means that the tangent of 315 degrees is equal to negative 1. All right, here I'm looking for the cosine of negative 5 pi over 3. Now, negative 5 pi over 3, again, because we have this negative here, that means I'm going to be going clockwise around the unit circle, okay? So if I'm going clockwise around the unit circle, I want to think about, well, I know that might be easier to change this into degrees then, right? So negative 5 pi over 3 times 180 over pi. Well, if I cancel out the pi's, and 180 divided by 3 is just 60, this is the same as negative 300 degrees. So here's negative 90, negative 180, negative 270. So if I go just 30 degrees here, that's going to give me that negative 300 degrees. So the situation that I have happening is I have a 60 degree, 30 degree, 90 degree special right triangle, okay? That's going to put me right here, okay? And that means that, again, the longest side is 1, the short side is 1/2, medium side is square root 3 over 2, all right? Because I'm in the first quadrant, that means that I'm going to have all positive values for x and y. So if we're looking for the cosine, remember cosine is the x value, and my x value is going to be 1/2. So the cosine of negative 5 pi over 3 is going to equal 1/2, all right? This is really, again, this is putting me in the first quadrant, so my x value is positive. And then number 5 here, we're looking for the tangent of negative 270. So if I think about my unit circle, again, it's negative, so I'm going clockwise. And here's negative 90, negative 180. Negative 270 puts me right up top here. Well, we know right up top, I'm moving 0 left and right and 1 up. And since tangent is equal to y over x, we know that the y value is 1 and the x value is 0. Well, we know we are never allowed to divide by 0, so that means that the tangent of negative 270 is going to have to be undefined. All right, you're never allowed to divide by 0, so that is going to be undefined. One last thing to think about, one takeaway, is that in your unit circle, remember anything in the first quadrant, your x value is positive and your y value is positive. In the second quadrant, your x value is negative and your y value is positive. In the third quadrant, the x value is negative and the y value is also negative. And in the fourth quadrant, your x value is positive and your y value is negative, okay? So keeping that in mind, remember the fact that sine is your y value and cosine is your x value, that's going to tell us right away that my cosine is positive in quadrants 1 and 4, and my cosine is negative in quadrants 2 and 3. That also means that my sine is positive in quadrants 1 and 2, and my sine is negative in quadrants 3 and 4. If you think about the tangent is going to be positive in quadrants 1 and 3, and the tangent will be negative in quadrants 2 and 4. So it's just kind of a quick guide to see if you're doing your problem correctly. It's just to look if your positive negatives match up with your sine, cosine, and tangent.